The method of analogues of circulation is a versatile method to do conditional attribution conditional to the atmospheric circulation. So how does it work? We start from a given day, let's say the 5th of November 2018, and we look at the atmospheric circulation during that day. Okay, so this is how it could be. So this is a hypothetical December of 2018, and those are analogues in the past, so circulation patterns that look like this one, but that occurred in the past or in a different period. So this is rather simple to obtain, and each of those days, of analog days, have a temperature pattern over, let's say, the North Atlantic, and we want to see and estimate how the temperature pattern that is associated with this one of this day is bracketed or estimated from the analogues of days with similar atmospheric circulation patterns, but which might have different temperature patterns. So how can we use this? We can use this to compute what I call Uchronic probabilities. So that's the probability distribution of temperature or precipitation for the same circulation pattern, but with or without human activities. So we simulate a monthly or seasonal temperature average from analogues of circulation by doing a random sampling of analogues from two different periods. So one with human activities and one without human activities. So we estimate the probability distribution of possible temperatures for atmospheric sequences that are close to the observed one. So the only thing that doesn't change is the atmospheric circulation, and we see how climate change affects either precipitation or temperature. So let's look at an example, which is the rainy winter of 2013-2014, where there were records of precipitation over southern England or northern France. And let's look at France, for instance. So if we look at circulation patterns which were the same as the whole of winter 2013-2014, and we look at the circulation pattern that occur during the period between 1950 to 1979 over the North Atlantic, the precipitation, the cumulated precipitation has this value, or this probability distribution, which is fairly low, so below what is expected. While if we take the analogues between 1984 and 2013, then the probability distribution is much higher and significantly higher. So we see that there is an increase of mean precipitation for prescribed circulation, and this increase really seems to be due to the human activities which changed between the first period and the second period. So that's an example, a very simple example or elementary example of an application of the method of analogues to determine the thermodynamical change, so the change due to the increase of temperature, on the change of precipitation.